for the sake of the video. Here's the basic y equal 2 to the x, based on this base of a 2. Okay. I calculate it. I graph it. I reflect these to get that thing, which is this. I graph it. Now, from this graph, then I can use transformations to graph that thing. What do? I take this graph and I shift it one place to the left and up 2. So 1 left and up 2 is what I've done on this one, and that would be my ultimate graph. Now, that, believe it or not, is the easy way of working this problem. This way is the hard way. What I've done is I've taken this original equation and I pulled the 2 over here. Then I converted this thing to exponential. And I simplified it down a little bit, so I got the x isolated. I ended up doing an XY table. If I put 2 into the y value, remember these are the y's, these are the x's. Okay? If I put it in here, 2 minus 2 is 0, 2 to the 0, 1, and 1 minus 1 is 0. Did you follow me there? Kind of complicated, isn't it? A lot of thinking. If I choose x is 3, 3 minus 2 is 1. So 2 to the first is 2. Minus 1 is 1. Right there. This one's too complicated. We'll go to 4. If I put 4 in here, 4 minus 2 is 2. 2 squared is 4, minus 1 is 3. Okay? And I could try a negative value too if I wanted to. But you know what? These are the same coordinates basically as those. Okay? And, but, man, that thing's a pain. No matter how you go about it, it is a pain when you've got that to do it. Now then, all that said, let's actually get started on where we've been. And here's where we need to be. Okay, graph the logarithmic functions. This one, actually, we just did this one. Interchange and find the inverse. Calculate the values of the inverse. Here they are. This is brought forward. And then flip them to get the original log or its exponential. So these are ultimately the points that we're going to graph. Do we have to graph these? No, you could for comparison just to prove they're an inverse, but honestly, if it doesn't ask you to do it, don't do it. Well, anyway, here are those values, and here's the graph of it. Okay. What about this one? This is the same thing as y equals 4 to the negative x. And for me, it's easier to use that than it is the fraction. Okay? X is 0. Anything to the 0 power is 1. X is 1. You flip and get 1/4. X is 2. You flip and get 1/16. 2 to the third is 8. 4 to the third is 64. And then you have to flip it because of the negative. On these, if it's -1, the negatives cancel. 4 to the first is 4. The negatives cancel. 4 to the second is 16. The negatives cancel. 4 to the third is 64. Then you flip them and you graph it. So here's the graph of this thing, like that. Okay. Remember the one before went up like this? What about this one? This we're asking a different question. We're asking about domain and range. Okay? We're asking about domain and range in this one. Notice what this domain is over here. What there really is there is an asymptote here at -3. Where do you suppose that came from? Right here, opposite of sign. So if you ever have a value with the x up here, that creates an asymptote. Okay? That will create an asymptote for you, which affects the domain. Now, there are no x values this way. This gets infinitely close to -3, but never quite touches it. Notice I've got non-inclusive, but it goes forever. Now, what is the range on this thing? Well, it goes down forever and up forever. Okay. Stands for vertical asymptote. Okay, let's look at this one. Okay. See that negative right there? That's going to flip it from being this way to being that way. Is what that negative will do. Okay. Anytime you have a negative y, a negative in front of the whole thing, flips it across the x-axis. What is the domain on this thing? Well, the domain, you've got an asymptote right here. Vertical asymptote at 0. And the domain goes forever that way. The range, from infinity to infinity. Or I should say from down infinity to up infinity. Okay? And we've got a vertical asymptote x equals 0. Oh, this thing looks nasty. That can be factored. That can be factored into this. Okay? You know what? That gives us 2 asymptotes. It gives us an asymptote at +4, and it gives us an asymptote at -1. Notice my scale is by 2s. So here I have these 2 vertical asymptotes. I've got them drawn in now. They call these boundary points, these two asymptotes. That's not something I really care about. But these asymptotes are sometimes called boundary values because it can't go no further. And here's on a number line, it's just showing you got everything outside of the 4 that way and everything outside of the 4 this way. Okay. What is the domain of this? Well, I've got a gap here. I've got from infinity over here to -1. Then I've got a gap. And then I've got from 4 to forever. What is my range? Well, negative to positive infinity. Okay. Sure. I care less about this piece right here. That stuff. You won't see it on my tests. Now, oh, were you through? Okay. Just showing you the difference in exponential functions and the logarithms, which are their inverses. Okay. If you graph these two in overlapping places, notice this point right here is right here. That one goes up that way and down this way, and the other one comes up down this way. Oops, not drawing it right. This way, okay, and they reflect across this 45-degree line. Once again, if you tried to overlay those two. Notice you got the 0.01, you got the 0.10 on the inverse. I mean, that's stuff we've hit before. The domains and the ranges switch. I've told you that numerous times. Okay. The asymptotes switch. Y becomes X. Goes through 1, 0, 0, 1. Flipped coordinates. Okay. Whole number power or whole number base, fractional base. Okay. Okay. That's just kind of a summary statement. All right. Now, properties of logarithms. Get out your handouts booklet. Pages 17 and 18 and 19, especially page 18. Because it's the neatest. And then after we get through looking at 18, then we're going to go back to 17. Which has what I am about to be talking about in the near future. Okay. All right, properties of logarithms. If you're on page 18 right now, what I'm showing you right now is the middle column on page 18. That middle column is the equivalent of the first column and the third column. Those are all equivalences. Remember, anything to the 0 power is 1. Well, what we're saying in this then, if I put this in exponential form, b to the 0 equals 1. And anything to the 0 power equals 1. So you see, these are equivalent statements. That's the point I'm trying to make on this. And there it is. Okay, what about this one? Anytime you see a B of B, A of A, 5 of 5, 9 of 9, it's going to be equal to 1. Okay. Now, why is that? Well, the explanation. Anything, remember, if we put this in exponential form, base stays the same. Here's the power, and there's the argument. Anything to the first power is itself, is what this one is saying. So here we're basically saying this is a power of itself, so it's 1. This is what I call the power rule. Now, there's more to it than this, okay? If you look at my page 19, I think it is. Okay. If you look right down here, where my finger is pointing. Now that's the power rule of expansion. This is the way I want you to learn this power rule and consistently do it. Okay. What I would have you do on this problem, I would bring this power out front. So this would become P log B of B. Okay. Well, this part is equal to 1. And 1 times P is P. Okay. But when you see a power like this, bring it out front and then deal with whatever this is. And it won't always be a B. They could be different base and argument. Okay. Power, as I call it. This is another variation of the power rule. Okay. In this case, your answer is going to be X because this part by itself is going to be 1. Always. Okay. Anytime you see something of itself, it's going to be the 1. Now, here's the product property. If you look on page 19, right here, where my fingers are. Okay. That's the product property. If we looked at problems like, for example, 3 to the 4th times 3 to the 7th, since we've got the same base, this would be the same thing as 3 to the 4 plus 7, or simply 4 to the, or 3 to the 11th. Okay. Now that's the rule of exponential that's in 6th grade. You're looking, did I write something wrong?
No, on Alex, we had this last week, and I believe you multiplied.
When you multiply with same base, you add exponents. Okay, that's the long-standing rule.
No, I understand what you're saying.
Okay, so I don't need to do that.
I don't have to think of it.
Okay, now, what has that got to do with this? I'm multiplying two terms with the same base. I was multiplying two powers by the same base. Here I added exponents. Here, keeping the same base, I add the terms. Okay? So this is the equivalent of that, which is what that line I pointed out on page 19 was. Okay? So let me erase this, and then we'll continue. Here's the division property. Remember on these, if we had 3 to the 4th over 3 to the 2nd, we made it 3 to the 4 minus 2 power. Remember that? Well, this is the equivalent of that. We have division, so we subtract them. Direct equivalence there. The power rule. If we had 2 to the 3rd to the 5th, this would end up being 2, in this case, to the 15th. Because we're multiplied by this. What we're doing right here by pulling this out front is we're multiplying that times the value of this. Likewise, over here, we could be saying 8 to the 5th. Okay? Which would give us the same ultimate answer. Now, again, anytime you have this power situation, in other words, an argument to a power, you pull the power out front, and then you have whatever your log is. Earlier, we would have b of b, but it doesn't always have to be. No pun intended. Okay, now, here's page 19, which shows what we just talked. And then we got, again, the a of a, and the a of a being equal to 1. All right, so if we've got this, we now need to expand this. Okay? We need to expand this. In this case, whoops. In this case, we're going to have actually 3 terms when we get through. Now, keep in mind, there is a hidden base 10 under this thing. Okay? That may or may not become important. We don't know until we get through expanding it. So what we're going to do with this then is convert it into that. Log 10 of 2 plus log 10 of x plus log 10 of y. Okay, that's that expansion. We are using the multiplication. When you have multiplication in a log, you add the arguments. What about this one? Well, this time instead of having a hidden 10, we've got a hidden 2. This one's going to have a special kicker to it. Okay? This one's going to have something special going on in it. Well, we break it out like that, just like we did this one. The only difference is there are 2's here, right? Guess what? We're not done. This one has an extra step. Look at this. So what's this first term equal to?
1.
1. So then ultimately, your answer is that. So you've got to watch out if any of the individual terms can be simplified more. Okay, what about this one? How many terms are we going to have on this one? Not one, more than one. 2, 3, 2. We got this one and we got that one. We can't do anything with this plus term. Okay, we can only deal with times terms. That sounds a little silly, I realize. Okay, so this breaks down into natural log of 3 and natural log of a plus b, and that's as far as we can go. Now, remember that this means log base e of 3 a plus b, like that. Just remember, natural log means log base e. In this case, it didn't matter. In some other cases, it will. Say what? What? Okay, I'm not sure I understand what you're. All I did was change this word to log base e. Okay, because ln means log base e. On this problem, it doesn't make any difference. Your answer would be log base e of 3 plus log base e of parentheses. Okay.
I've seen some other ones that you have to like multiply.
Okay. Or at least I think, if I understand what you're asking, I think we're headed there. Okay, what about this one's a division? We'll get to what I think was the question, but it's going to be 2 or 3 or 4 minutes. Okay. Here, I'm going to have a subtraction, aren't I? If it's in the denominator, it's going to have a minus in front of it. If it's in the numerator, it's going to have a plus in front of it. Okay. So this breaks down in log 7 of z minus log 7 of 49. Now, here's what you were wanting to know. 7 is the power of 49. 7 to what power is 49? 2. So that means that this thing is equal to 2. Okay. Now, there would be your final answer on this one. Now, you ask about E. It would matter if we ended up with an E of E thing. Okay. And we will have one of these in a little bit. Okay, here's another division. So we're going to have a subtraction on this one. Log 7 of A and log 14. Now, even though 14 is a multiple of 7, it is not a power of 7. So there's nothing we can do with it. So that's just the final answer. Okay, log 100 over x plus y. We've got to treat that x plus y as an entity, as a single thing. Okay? And we're going to have a minus. And up here we'll have a plus. So we got log of 100, log of x plus y. Except we've got a hidden base 10 here. Okay. 10 to the second is 100. So that means that this whole thing is equal to 2. So then there is your answer. Questions?
So, on the other one, when you do the x plus y
Where? Which one?
at the bottom. you
That
see log
here.
X plus y, you would separate it as log x plus
No,
y.
because it's a plus. They have to be times. If that had been XY on the bottom, you would be correct. Okay, but X plus Y, nope, they just stay as a parentheses. Okay, good question. Okay, here's a couple more. Let's go ahead and do these. You do these two. Easy for me to say. I'm terribly thirsty tonight. Earlier today, I had started to get leaves up with my garden tractor. We have 34 trees in our yard. Yard was almost a foot deep in leaves in places. And so I got out my lawn tractor with a bagger system to get them up. First time I put it in and the blades rotating, pop goes the belt. So I get a belt and I start on, and it's the belt. The belt they gave me was the one for the transmission, the drive. So I go back to the store, get the right belt, put it on. Then I pick up leaves. Well, picking up leaves, just something about it dries you out. And also it's way too hard for an old man like me to work. Okay, we ready on these? I guess I have to work these. I don't get the benefit of the doubt on this one. So I've got log 6 of 8 minus log 6 of t. 6 and 8, no power, so I'm done. On this one, natural log e minus natural log 12, except this means log base e of that e minus log base e of 12. That right there is equal to 1, so 1 minus log or ln of 12 would be your final answer. And I finally got to your question, I think. Or not? Oh,
So when we get to
okay. Well, I thought this was basically what you were asking me. Why would we want to convert to E, base, log base E? So I misunderstood your question, I guess. Okay, let me get rid of this stuff. We can keep on going. Power property. First thing when we do on this one, pull the 5 out front. And in this case, we're done. This one, we're gonna get a little extra step in this one before we're done. We bring the 5 out front again, but Ln of E is the same thing as this. And this is equal to 1 times that 5, so the answer is 5. We got to convert this to fractional first. Remember, this is always the denominator. If there is anything under here, it is the numerator, and if there's nothing, it's a 1. So this becomes that. So we use the power property and bring the 2/3 out front, and in this case, that's as far as we can go. Did I go too fast?
Yeah, you go back.
I am back. Okay, anyone not ready still? Okay, now, at this point, to this point, we've been expanding. Now we're going to contract. Instead of having these, we're going to get a single logarithm now. So we got to do just the opposite of what we do. If we got a plus here, it's a times in the numerator. If we got a minus here, it's a denominator. Okay? So in this case, they skipped a step. Well, actually, they didn't. They didn't even do this the way I told you to do it. What I just told you to do is change this base 8 of 8 times 1. Okay, this could be that, which is still 8 of 8 is 1. They instead said, okay, that's 1. And if that's 1, that's 0. Just two ways of doing the same thing. Okay. Okay, we're going to expand this one. We're going to have 2 timeses, 2 pluses, and 1 minus, which gives us that. Now, after we've got that, we've got to look at each individual one and see if we can simplify it any further. And in this case, we can't. Here's another one. This time I'm going to have 2 pluses and 2 minuses. They're going to show you a little different way than what I've been telling you. Okay, or I think they may. Nope, they did it the same way I would have in this one. In a moment, they're going to do one differently. Okay, here's the log base 7 of A, the log base 7 of C. They're both a plus there and a plus there. And here we have minus log base 7 of 5 and log base 7 of D. Question on that one? Yes.
So anything in the denominator, when you expand it, is it just going to be a minus?
Always. Yes. Because of that division of powers rule, where you subtract the exponents. Okay, what about this one? Well, this one's going to take multiple steps. First, we're going to have to break it down into this. In other words, separate this x squared and this y. Then we're gonna have to use the power rule and pull the 2 out front. And in this case, that's as far as we can go. Although that means log base E, there's nothing that we can simplify with. Now we're getting even nastier. Okay. First thing we got to do is convert that to a fraction. Okay. And because it's in the numerator, it is a plus. This is one term. And it has to stay together in a parentheses. Okay? Because those aren't multiplied together. So you get this thing. Now, we're not done yet. We got to use the power rule and take that out front. And that would be the final answer on this one. Now, all of that's under this radical. So we better change it to half power because there's a hidden 2 radical there, or root. Okay, so the half power of everything that was in that thing. So all I've done so far is I've changed this to fractional power. Now then, I'm going to bring this half out front, right here. And I still got this whole mess of stuff to deal with in a minute. So then I have that half that's out front of everything. And part of it, I break down into the 4 and the x, both pluses. And the y, a minus, and the z, a minus. Okay, now, anyone got a question before I go to the next step? Because we're far from done on this one. Okay, here we go. What do you think I'm going to do? I'm going to use the power rule on this. Okay. Like that. And that's all done in that step. Okay. Now, I can deal with this. 2 to what power is 4? Second. So that means this whole thing is equal to 2. Anything else I can treat like that? Not really. So now my last step is to distribute this 1/2. Okay, and that 2 is where this 1 comes from, half of it. And then a half times that term, and a half times that term, and a half times that term. And that would be the final result. Questions? This is kind of long-winded, isn't it? Well, what about this one? This one is going to be a whole lot better. Okay. We're going to have a power rule in a minute. We got 2 plus terms and 1 minus term. Now, I would not do it this way. I would not do it this way. I'm going to go ahead and put their steps up here. Okay. But I'm going to go directly from here to here. Let me reason you through this. Log 3 of x plus log 3 of y cubed. Well, I'm not gonna go straight to here, but I'm not doing it the way they did it. Minus log 3 of z squared. That would be my first step. Okay? My second step is, this is just going to be the same here. I'm going to bring this 3 out front, so I now have plus 3 log 3 of y. And I'm going to bring this 2 out front, so I've got minus 2 log 3 of z. Okay? And now, as you see, I'm at the same place they are here. Now, this is what works for me. If you want to group these and then have that tag along minus, you can do that. But I think it's unnecessary opportunity for errors. Okay? So anyway, that's how I would do this. Now, I do need to look at these and make sure I don't have anything I can further simplify, and I can. Okay, we got another radical, which means we got another fractional. I would never do this. I would never do that. You can, it's okay, but I sure as heck wouldn't do it that way. I would go straight. Well, let me show you what I would do. Log. And this is base 10, so I'm just going to write log. And here I'm going to have x plus y to the 1/2 numerator minus log of 10. Okay. Then I probably would do 2 log of x plus y log 10. Expand it as much as I can expand it. I can remember that there's a hidden here. So I've got a 10 of 10. This thing is equal to 1. So what do I end up with? 2 log of x plus y minus 1. Now that's the way, that's the approach I would use. There's nothing wrong with the other one. Okay, yes.
Would the 2 be 1/2?
Yeah, actually, you're right. You're actually right. That was pure carelessness. So let's put that there and let's put this here. Good catch. Thank you. No wonder I was getting some strange looks. Puzzled looks, like what the heck's going on? Okay, any questions about this now that it's corrected?
Where did the 1/2 come from?
Right here. I brought it forward in the power.
But how did it, oh,
The square root, remember there's a hidden 2 root there. And a hidden first power on that parentheses. Okay. The root is always the denominator, and the inside is always the numerator. And I'm glad you asked that, because that's really something that gives a lot of students trouble. And that's, causing you to make errors. Okay, well, anyway, there was the answer. Here we go, a new one. Okay, I would do this same first step. The next thing I do is I bring this 1/5 out front of everything. Which is exactly what they did. Now, I'm going to put a brackets with that 1/5 out there, and I'm going to use the x to the fourth and a minus y and a minus z cubed. Okay, that's exactly what I would, well, actually, I probably wouldn't have done this. I probably would have gone ahead and expanded them at the same time and make this log. Make this log be y minus log b of z cubed. Say again. Is it in the denominator? If it's in the denominator, it's got to be down here. You don't look convinced. Okay. If it's in the numerator, it's a plus term. If it's in the denominator, it is a minus term. Now, what they did here, the way they did it, is eventually you're going to have to distribute that negative to both of these. Which in my case, I made them both negatives to start with. Okay. What? No, I've done it this way. If it's in the numerator, it's been pluses. If it's been in the denominator, it's been minuses in every case. You don't still don't sound convinced. Okay, see here, they're having to distribute this negative now to get to the same sidewalk.
It's right there.
This is the same thing I have here. Yeah, I've got a minus there and there. I've got a minus there and there. And I've got a plus in this one. This line and with my blue are exactly the same.
It's the middle one.
What?
The middle one will be off, but now I know because you multiplied everything with the negative.
Yeah, anything, if it's in the denominator, just put it with a negative to start with. Okay? If you go this way, the odds of getting to distribute it to this one are way too high. Okay? So that's why I say do it from the first. Well, anyway, from here, we haven't got anything. Well, we can bring the 3 out front. We can bring the 4 out front. Let me erase this stuff. Okay, here was that last step on the other slide. I brought this 4 out front here. I brought this 3 out front here using the power rule. Okay. Now, the only thing left to do is to distribute this 1/5. Like that. Actually, as far as I'm concerned, this answer is as good as that one. Just watch out for whatever one Alex wants. Okay. Alex may make you distribute it. Alex may not make you distribute it. 1/5 times 4 is 4/5. 1/5 times hidden 1 is 1/5. 1/5 times 3 is negative is 3/5 with their respective signs. Well, here we go again. Eventually, we're going to have an 8 of 64 to do some simplifying with. So, they did this one the way I would have done it from the beginning. If it's in the numerator, it's a plus term. There's a hidden plus right there, a plus there, and a plus there. If it's in the denominator, there's a minus, there's a minus, there's a minus. Okay, this is exactly the way I would do this one, instead of the way they did the last one. Now, I've got to bring all these powers, this power and this power forward. Okay. So I'm going to do that. Now, they did two things at the same time. Not only did they bring this 2 forward right here, this 2 is right here, but at the same time, they took this step. 8 is the second power of 64. 64 is the second power of 8. So that means that all of this has a value of 2. So they replaced this 2 here. And then here, they brought that 2 forward. And they brought this 3 forward. And this would be the final answer on this problem. I'm going to keep going on these. Now, we're going to contract. Just the opposite of what we've been. Okay. Got 2 terms. Both the same base. And that's the first thing you got to check. So I can contract these into, this is in the numerator because it's a plus. That's in the denominator because it's a minus. And that's as far as I can take this one. Any questions on this one? Okay. Here's another one.
I'm sorry. Would you be able to simplify by getting rid of the x denominator and the numerator?
I don't have an X over here, so there's nothing to cancel with. Because there's a plus or minus in here, it's all for one, one for all. Okay. The only other thing you can do, and it really wouldn't help, is you could change this parentheses to 4x over x minus 3 over x. And then you could do this 4 minus 3 over x. And there is absolutely no gain in doing that. Okay. If anything, it makes it more complicated. I mean, you could do that, but there's absolutely 0 point in doing it. But if there had been an x and a 3, your question was correct. Okay, this one. First thing I did was I unpowered this 4. Or repowered, I guess is the right word to use. I repowered this 4. Then the next thing I'm going to do is I'm going to put both of these terms with a single log 2. So this one is positive, this one is positive, that means they're just multiplied together. So I've got the y to the 4, I've got the z there. Question? No? Okay. This one's a little longer. We're going to have to keep that x minus 2 together all the way. Okay. I've got a repower here I need to do. I need to repower that 3 like this. Now then, all of these 2 are pluses, That one is a minus. That minus is gonna go in the denominator. These two are gonna be in the numerator. With a log in front of it. So here's the x cubed. Here's the parentheses, which has to remain intact, minus the 5. We're getting even nastier. This is gonna have to be repowered at some point. That's gonna have to be repowered as a radical eventually. Okay? And I don't know why they left these already repowered. But we'll go ahead and deal with what we got. Okay, so here we go. All I did so far is I distributed this 2 first. Times this whole brackets, okay? Now, everything else I just brought down. Now then, the next thing I'm going to do is I'm going to repower this 2. I'm going to repower this 2, which is going to give me a 4 over here. I'm going to maybe repower this one now later. So let's see here what we got. We took this repowered here, got a 4. And 2/3 times 9 is 6, so we don't have to put it in radical form. Okay, and then this one's just tagging along for all individual terms, so we can start putting them into one term. So we're going to write Ln, and then a big parentheses, and then we're going to put my 2 positives in the numerator. My 2 positives in the numerator, and my 2 negatives and then there's one more step we can do. We can simplify this x squared over x fourth to 1 over x squared. This z to the first and z to the sixth, 1 there, and z to the 5th here. So I've got z to the 5th over x to the 2nd. Okay, you're frowning. Okay, which part? How did they go from this to that? Well, these are in all in one parentheses, and these are all multiplications and divisions. So you can cancel up and down any way. Okay, I basically pre-reduced these x squared over x fourth. 2 of these, if you had x to the square minus divided by the 4th, that would be x to the negative 2nd, or 1 over x squared in the basement. It's easier to just cancel them this way than to try to do it that way. Over here, I got 6 on top, and I'm going to divide out 1 on bottom, leaving me 5. Okay, did that make sense? And so that's how I got that final step. Okay, this one, we got this that's going to have to be repowered behind that parentheses. And actually, that can be broken down into x minus 5, x plus 5. So here we've got this. All we've done so far is we put the 2 back here on the parentheses. We've repowered it. This went up here. What else did I do? That one, nothing. This one, eventually we're going to have to do this. I think on this problem. So let's go on to the next step. Okay. We're starting to pull stuff in the numerator and denominator. This one is a minus. So x plus 5 squared has to go in the denominator. This one is a plus. So here's the x from this plus. And this one is a plus. So here is the x squared plus 25. And it's all log base 5. Now, this thing will factor as we said earlier. And because it'll factor, those can complete, because really there's a super parentheses around that. Yes.
How did the x plus 5 and the x minus 5 cancel?
Because I drew it wrong. These are x plus 5, x plus 5. Okay, I didn't look at what was carefully enough. Let me do this over again. Thank you. This x plus 5, either one of these will cancel with that. These two are going to have to stand. They're going to stay there. And also that x. So here's what you're going to end up with on this. For some reason, I was thinking it was x plus 5, x minus 5 on both the numerator and the denominator, and not paying it close enough attention. Okay. This one. Log 2 of that thing, I bet that's going to be able to break down. Because, well, we'll see. Log 7, no. Oh, don't need these. We want to bring it all back. I've got a positive here and 2 negatives. So basically, this is going to be, and I wouldn't show those steps, I go straight to this. I put my positive on top, my 2 negatives multiplied on bottom. Okay. Now, 7 goes into 56, right? So if I did some canceling, that would go once, and this would go 80 times. Okay, 5 will go into 80. 5 goes into 5 once, and 5 goes into 80, I think 16 times. Someone multiply it out to verify me. Okay, so that means this whole thing is 16. Now, or you could do it that way. You can divide 35 into 560 the long way. Either way, you'll get 16. But 2 and 16 are powers. Fourth. So that means that all of this on the bottom, at the bottom, ultimately becomes 4. And I sure wouldn't do it this lot. I'd say 2 is what power of 16, 4 is the answer. I mean, why put yourself through extra pain? Okay. Now, want to hear some good news?